Hello, everyone. Yeah, we can hear me. So I'm going to take you through a bit of a story that we essentially had in our team. I work for the fraud prevention team at Vodafone, and it's called Man in the Middle. I'll kind of explain what that is. Just really quickly who I am. I'm not going to go into too much detail here, but academic background in terms of software engineering. I've done a bit of data science. My career at Vodafone started in 2013. I was a data science manager for a little bit of time and then moved into the fraud prevention team. And why I moved into fraud prevention was I could do real world impact. Working in the data science team, you were essentially serving many of the other teams in the organization. I wanted to do something right on the front line. So, essentially, how do we use Teradata in Vodafone? So we have tactical data that goes in, and we also have strategic data that goes in from our IT team. So we have a fraud technology team, so they'll bring in data that we may need into our own database and Teradata, but we also use much of the strategic data that also goes in. And off of the back of that, we do lots of things. So we do proactive scripts, so we look at proactive detection, we build ML models, which is what I'll go through today, and we also do fraud alerts. And what we're using now is ClearScape Analytics. A lot of the stuff that we'd done before was essentially just rule-based logic. So essentially, we would have a rule, we would flag it, but that essentially brought problems in, which I'll take you through. So it'll be interesting to know if anybody else is suffering from man in the middle, if you work in a sort of a fraud area, if it's banking or telco. What it is essentially, we've seen a surge of this sort of activity in 2023, and we've seen a sudden increase. So essentially, man in the middle, it targets high-value devices, it targets new activations and existing customer upgrades, and it resulted in lots of financial losses. So it involves impersonation between essentially Vodafone or any organization and the customer, and someone sits in the middle of that. So what we see is interception first. So this is a typical way that they might do something. So they might say, look, hey, I'm Vodafone. How are you doing today? You may think that that's who you're talking to. You'll get this call out of the blue. Then it's the manipulation. So what they're possibly going to do is give you an offer that's far too good to be true. So, hey, I've got this new iPhone. We want to offer you at a really cheap price. They may give you some excuse, along the lines of, we know that you've complained recently or something like that. And then you'll essentially go for that deal. But then what actually happens is there's an execution to this. So they'll essentially get into your account, place an order, and then off the back of that order, they'll order you the wrong device. Once you receive it, they'll then rescam you again, and you'll send that device to them to a mule address. And that's how they get a hold of the device. It's really dangerous because it seems legitimate. Customers are often unaware that the device is gone, and it's difficult to detect, especially on rule-based applications. Here's the surge that we've seen in late 2023. Now, the green line, I can't put any numbers to it, but I'll give you some context. The green line is the amount of devices that we were saving. So that was our fraud analysts, essentially working off the back of our rule-based logic, saving the devices. The red line is how much devices we lost. Now, over the last, since this year, and it's the numbers that came from CIFAS, which is a fraud organization in the UK, where we essentially load all fraud cases into. Basically, 2 out of 5 fraud cases are man in the middle, and they project around about 35 million a year is lost on this essentially fraud tactic. So we put in countermeasures to begin with. That was the first thing we'd done. So we'd done things like flag suspicious orders. We looked at basically putting on, sending text messages to customers to say, hey, did you really order this device? We put stickers on boxes. We put fraud warnings out, things like that. But what happened was that saved a lot of devices, which was great, but it led to limitations of very high false positives. So, the fraudsters were able to adapt. There was a lot of, essentially, our fraud analysts were spending so much time essentially working on cases that were essentially not fraud. So we had what we would call high recall. We were looking at a lot of cases, but we weren't actually spotting a lot that were actually legitimately fraud. And fraudsters adapted quickly. So they started kind of changing their tactics, which rule-based logic just doesn't work for. So the approach was ineffective, and what actually happened was our analyst resource went sky high. So basically all that was happening was our fraud monitoring team and our fraud analysts were just spending all their time looking at these cases. So why we needed a better, essentially, detection process. So we required something that was smarter, that was able to adapt. We needed something that was machine learning and the ability to continuously look at different fraud behaviors. And this is why we chose ClearScape. So this was our first model that essentially we wanted to take into production. So essentially, I'm not going to go through this whole slide because I think it's actually quite easy of why did we choose ClearScape over all of the other ones that we could choose? Because there's many different platforms that are out there. But the main reason I'll sit here and say is all our data is in Teradata today, okay? So why move the data elsewhere into another platform to do the machine learning? Why do the feature engineering into another platform? We didn't want to do that. And one of the other reasons was privacy and security. A lot of this data was PII, so getting past privacy and security could be difficult, but we didn't need to do that because essentially all our data resided where it was. 2 seconds. So it was a familiar platform. Our analysts, the analytics guys that I work with that build the proactive detection, may not know machine learning, but they know SQL really well. So they were familiar with that platform. We didn't need to build any new pipelines. We had independence. So I didn't have to rely on a data team, didn't have to go to the data science team. We didn't need to bring in big data domain and things. We were able to do it all in-house. It was ML ready, and obviously the data security there as well. But it was also cost effective, and that was a big point. We didn't have to think about compute costs and everything else that is associated with essentially ML models. We were able to do it at no cost to us, essentially. It was all built into the platform. So we built everything in SQL. Everything that I'm going to show you, there was no Python at all. And many data scientists will go through Python or Spark or use Databricks. This was all done in SQL. Just in Teradata Studio, as easy as that. Take the data, do the feature engineering, do the ML modeling, score it, predict it. That simple. So while Python is available through packages like Teradata ML, we didn't use these for this one because we just wanted fast deployment. So we've done data preparation. We took all the data that essentially is in our database, we pulled it all together, and we built a physical layer. And off that physical layer, we've done feature engineering. So rather than using, as I say, Python or something like that to do the feature engineering, we've done it all directly in SQL inside Teradata Studio. We normalized, we scaled the values, we applied custom undersampling, everything like that. That's all available through ClearScape Analytics. And then we've done the modeling and the predictions. So we trained an ensemble model, which I'll take you through. We tested and tuned it. We evaluated the performance, and we deployed directly into production without moving any data. And this is something that's really important in the last bit, which again, I'll take you through later, but it's the explainable outputs. That's what really helped us get trust in the model. So we used SHAP, again, inside ClearScape Analytics to give reasons for why the model flagged certain instances. And we integrated the outputs into our fraud management system. So we have a fraud management system. It's a front end, so we can essentially, any cases that need to be reviewed, we can push that into that system so that fraud analysts can then review it. And again, all done in SQL. I'm going to read a little bit here. I don't particularly like just reading slides, but in terms of what we did, this is how we looked at raw sources, built the ETL pipeline, the physical layer to get ready for feature engineering. So we developed that dedicated physical layer. We wanted trusted data to be available to us, and we wanted it in one layer so that we could access. So rather than accessing lots of different tables, we made sure that the data that we had sat in one physical layer inside Teradata so that we could then build the features on top of it. We analyzed every order in near real time. We identified suspicious calling patterns. So what we looked for was this customer just contacted by someone out of the blue? Did they contact that customer before? So we were able to do that with our CDRs. We looked across the whole network, so we analyzed billions of calls per day. So we were able to do that, again, through the CDRs. We then looked at things like unusual customer behaviors. Did they change the password? Was their email changed? Things like that, which we were then put into the physical layer ready for feature engineering. And we kept that layer separate from the modeling. acting like a feature store for attribute selection. So why it matters, quality and trust. Data assured via internal assurance processes monitored through the source systems, and the speed. It's really quick to do if it's all sitting in the physical layer or if you need to make changes. And consistency, it's one source of truth. So any type of man-in-the-middle modeling that we were doing was all coming from that one area. But what we learned was to treat the data prep as a product, design it for reusability, separate your physical layer from modeling logic to enable fast iteration, and implement ongoing monitoring to ensure upstream changes don't break key inputs. So we found that that was really important to do in terms of the models, that you didn't want to do something downstream that could affect upstream. So in terms of the feature engineering, we built this physical layer, and off the back of that, we then used scale, encoding, everything like that, which we normally use in standard ML practices, just directly in through Teradata Studio. We built all the signals, so call, SMS, proximity, first-time callers, account changes, all of these features were built. And then we done data balancing, and we essentially done our own undersampling. We could have used Smote's a process that you can use for essentially creating synthetic records, essentially, of fraud, but we didn't want to do that because we wanted to essentially, we had so much data, we wanted to undersample it. So what we actually done is we just used a KNN function. It's really important in fraud that you don't possibly create synthetic samples, because in real-world production, you probably wouldn't see that. So we used KN, we used k-means plus plus to balance it. The reason we really needed to balance it was because the level of fraud against non-fraud is so high. You know, you'll see 1,000 orders that are not fraudulent to one fraud order. So it was really important that we did try and balance that. So again, why it matters, consistent high quality inputs reduce the model drift, and balanced realistic data sets improve generalization to help find the general fraud patterns. So it's about making sure that the sample set that you're getting, that you're putting into the models, are essentially reflective of real production. And the processing was fully done, again, inside ClearScape Analytics, ensuring speed and security and avoiding errors from moving the data. What we learned was always ensure features are encoded and scaled. Again, just making sure everything is normalized. And carefully weigh upsampling versus undersampling. Again, we find that that's really important. We did try with undersampling, we tried with the oversampling, or upsampling, and we definitely found that the undersampling was working better for us once we got the KNN function working. So this is where we then start doing the modeling, which is probably the most interesting part. And one of the things that we wanted to do first was just look at the actual models that ClearScape gives us. You can use BYOM, which is essentially bring your own model. So what you could do is you could have models elsewhere that you've possibly produced. You could export them through like PMML or ONNX, and then you could also run them in the database. But we didn't want to do that at first, because why? We haven't actually tested our baseline, so we wanted to see what ClearScape could offer us first. So we trained an ensemble of 3 built-in models, and this is the ones that we used. We used GLM first, because GLM is great for linear correlations and things like that. So we went with that one first, and it's a really good baseline. We then used Decision Forest, because it's the opposite. It looks for non-linear relationships. And then we used XGBoost to look at more nuances and different types of complex fraud patterns. Those 3 models go to a hard vote classifier. So the hard vote basically just means if any one of those models says this could be fraud, then essentially it will be categorized. And then we put it into simple categories for our fraud analysts: very high, high, medium, and low. So essentially they could work out which ones to tackle first. We got some really good scores from the model as well. So a 0.84 macro F1 sounds really technical, but essentially it's just a balance of, you know, that the fraud is much less, it's a much lower score. So basically the 0.84 was basically telling us that the model was able to distinguish between fraud and non-fraud really well. And we got a 0.91 AUC, which is extremely high for that type of model. So we were able to identify the fraudulent orders really well. So this is just saying exactly what it is. And we also reviewed the feature importance, just to make sure that the actual features that were in the modeling was working for us. So we find that definitely using ensemble helps, because each of the model does its own thing. So using that ensemble with a hard vote massively helped in terms of identifying the fraudulent behavior. I'd start with the built-in models is something that I could recommend. You don't need to over-complex or bring in really complex models to something where you haven't tested the baseline first. Go with the stuff that's easy, see what sort of baseline you get and then improve on from there. With the scores that we got, we could look at bringing our own model in, but what additional benefit is it going to bring us? What's going to be, rather than tackling another problem, do we really want to spend lots and lots of time trying to do something more complex? And blend the models together, like I said. Use 3 distinct models that can really help in terms of identifying what you need. Because this is just a classification problem. It doesn't just have to be for fraud. Any type of classification problem that you've got could be dealt with through this sort of modeling. So probably the most important part. As a data scientist, when I was working, one of the hardest things was getting people to trust your model. So you would have an output, and you would say, try and trust the model. This is what it's flagging. But it's very, very difficult. People want to disprove your model before saying that it's actually helping you. So what we did was we used SHAP, which is another feature inside ClearScape, and it's probably been heard from by many sort of data scientists and things, to essentially give us an idea of why something is flagged. And what it does is it looks at all your features from the 3 models that we've got, and if it's significant, we've put some natural language around it. So this is actually what the model says. So I actually just copy and paste, other than the phone number, because I didn't want to put any PII data in here. But this is actually what it says to a fraud analyst. So it'll say that there was a suspicious inbound call from a telephone number. It was received 12 minutes before the order was placed, lasting 16 minutes across 2 calls. During the call, the customer received a one-time access code. The account password was changed, and the caller matches historical fraud patterns from other customers on the network. The device is also high risk. No other calls have been seen between that customer and the number in the past 30 days. So that's all based off the features. We put all those features in, but then what we done was when those features flag, we essentially had natural language to then give to the fraud analyst so that they could then make the decision of, does that look like fraud? And they then make the decision on the back of that. And that really helped us deliver the results, because once fraud analysts felt that they were in control to make the decision, they trusted the model. It also ensured that the outputs were consistent. So consistently they get, and there's lots of different patterns and lots of different language that can come out, but they get very familiar with the numbers and the times and things like that, so they're able to make decisions quickly. So it builds trust. It reduces investigation time massively because they see so much of it up front, and it enables the proactive action. In many cases, fraud is detected before the customer is even aware. Again, what we learned was, link models to outputs of real-world indicators so your analysts understand why something's been flagged. Keep it explainable and concise, and integrate directly into analyst workflows. So this is exactly what they see in our fraud management system. They'll go in, and this is the case notes that they will have. So just a couple of things to go over. Deployment was done all in SQL. I know I keep saying it, but so many people are so quick to get straight to Python or use a particular tool. If you're already on Teradata and you're on 1720 and you've got ClearScape Analytics, use it. Even if it's for tactical approach, try it out and see what you can get from it, because it's more powerful than a lot of people think. We focused on fulfillment of orders, so we didn't look at retail, we just looked at the orders that are essentially going to be dispatched. So that gave our analysts time to essentially make those decisions and stop those orders. And frequent retraining, we retrain our models every morning. So early morning, our models are retrained, and then they're scored every 2 hours throughout the day. So we do that continually. Ongoing assurance, so we have dashboards, essentially, that will tell us the drift, what the scores are. So every time it's retrained, we get the AUC, we get the Gini score, we get the recall, the precision, the F1. It's all stored into our database so that we can understand, is this model drifting? Now, Teradata also has model ops capability. It's not something that we currently use, but you can also use Teradata's model ops capability to do the same thing. And it's really easy to maintain. One of the areas that was crucial to us is a lot of my fraud analytics team doesn't know Python. They've been built on building rules in SQL. So essentially, I'm able to explain how the machine learning modeling works, and they understand it in a language that's familiar to them. So it's really easy to expand it out. So business value, which is probably one of the most important things because we built this model, but we also wanted to show that it was bringing in value. So what does it do? So since the significant costs in device fraud, in terms of it being deployed in 2024, we've seen a massive decrease, hugely decreased. So it contributes around 70% of our total savings in fraud. That's how much the model does. It frees analysts time so that they can actually do other things, tackle other fraud that's going on within our organization. And it's linked to Power BI dashboard to provide real-time visibility of cost savings. So if my seniors go in, they can see exactly how much we're saving by using this model. High accuracy and low customer impact. So 50% more effective than our legacy rules. So essentially what we done was we looked at what our legacy rules were flagging, and then we put the ML on top of it to say, this is how much more has been saved. And when it flags, when I showed you those categories, the very high, if something flags in very high, 82% of the time it's correct. That's how accurate it is as well. Now, we did bring in more recall, so the ones that come in at low, we push that recall up. What we do is we have a thing called a utility sweep. So we look at the amount of resource that we have and the time that they have, and then we work out what kind of recall we want from there so that we can understand if we've got these fraud analysts, we can essentially give them more or we can give them less. So we have this variable threshold that allows us to essentially give them more. So a lot of the ones that are low may not flag as fraud, but even if, say, 20 of those are not fraud, to capture the one, it still works out more beneficial for us because it's about £1,000 a device that we would lose compared to the resource time of the actual fraud analyst looking at it. It works out better for us. And fraud is caught proactively. So most of the time, we will tell the customer that they've been a victim of fraud, not the other way around. So agile response as well. So what we are able to do is if a new MO comes up, so one of the ones was the fraudster started getting a bit smart, and what they started to do was spoof Vodafone numbers. So you were getting a call, but it was also showing you that it was coming from Vodafone. So we started being able to detect that through our CDRs again. So basically we were able to then work out, well, Vodafone hasn't called the customer. We were able to build that into the model really quickly, just as a feature. The feature was just basically spoofed number, and it was just a positive one, essentially, if it was. And the model learned really quickly to look for these because it had seen them in the past. eSIM swaps. This is something that we're starting to see a lot now, and we were able to build that into the model as well. So again, that's where a fraudster will do the eSIM swap and then do the order on top of it. We were able to build that in really quickly. And we're able to do that because it's just, again, all within Teradata Studio. It can be picked up and we can deploy it. We can deploy these changes within days. We don't have to go to a data science team, wait for PI planning, wait for them to pick it up, because their resource capacity is maxed out as well. It's not their fault that they can't get to it as quick as we want them to. It's just that we need to work faster and we can't wait for them. So this is something that we're working on now. It's the next thing, and I think I'm going through it on the roundtable. I am going through it on the roundtable, so I won't go into too much depth with it. But essentially, it's our feature store that we're building. So what we're now looking to do is essentially, of all our proactive detections that we're trying to pull together, we're building it into a feature store. So rather than just having man-in-the-middle features, we're essentially building all the different fraud features into modules, and then we're putting it into a feature store where we'll then put role-based logic and machine learning over the top of it to essentially send through to our fraud management system. So it's a much bigger project, but it's working really well for us at the moment. Now, just give me a second to have a bit of water. Just before I wrap up, we had some, it only came out just before, a week before I came out here. The Metropolitan Police were doing an investigation. So this kind of helped us show that it worked. We're now Vodafone, I don't have my badge on me, but we're now VodafoneThree. You'll see it in the bottom corner. So I'm Vodafone. We've recently merged with Three. Now, within Vodafone, we've done a lot of proactive detection. We would try and detect the fraud up front and then essentially reduce it that way. What Three would do is they had brilliant investigators. They would essentially allow fraud and that to happen, but they would put trackers and phones and things like that to find out where they were going. So the Metropolitan Police actually found a consignment at Heathrow Airport. And in that, essentially, consignment was hundreds and hundreds of phones, all linked to man in the middle. Now, we have a very big market share in the UK, and we only had a handful of phones in that consignment against all the other networks. So it goes to show that we're able to really prevent this fraud against others. Again, I'm happy to go through anything that has been given in the presentation, and as I say, I'll be going through some of it in the roundtable as well. Thank you very much.